So Hanji Palwan ki halchal. Welcome back. I'm gonna start with what is the difference between uniformed, uninformed, and informed searches. So first of all, uninformed searches are like they just go in all the directions. For example, if you wanna go from Vancouver to somewhere, say Abbotsford, it'll go from Vancouver in all the directions, say to Burnaby or to Coquitlam, but not specifically to, you know, Abbotsford. So it's like kind of uninformed search. Like they do not have more information about the main problem, and basically they blindly go in all the directions, and they depend upon the depth and path cost. For example, we have the depth first searches, breadth first searches, they are uninformed searches. Whereas when you go with informed searches, they uses special algorithms or function called heuristics about the goal, because they have information about the goal or the endpoint, so they can make an appropriate decision related to that, and they can find the direction. And you can see towards my left, I have created an A-star search that basically uses heuristics and is an informed search. So what is an heuristic? If you say, it is basically the function that tells us that how close is goal to us, and it'll design us a particular way for that problem. So if you go with the heuristic admissible, like when is heuristic admissible? So it is just like the non-negative heuristic function that is an underestimate of the actual cost of the path to the goal. And I'll show you something more. So h of n is an underestimate. So if there is no path for n to the goal, so at that point the heuristic is admissible and it is non-negative, and it should always be less than the particular goal node. Like for example, yeah, so you can see, I'll just explain that thing. So this is the h of d. So if it's less than or equal to that thing, it is admissible. So basically admissibility is its non-negative and it's underestimate of the actual cost of the path goal. So in this, if we complete the first question, and here comes the next one. So here we basically used to find out the cost arc of the between the paths from A to C. You can see from A to C we have 3 and 1, and when you use this formula, you can find out the actual cost, like how much does it cost, or like how far is the distance. So for A to C, it's 3 minus 1, it's 2. For A to B, it's 4 minus 1, 3. For B to D, you put this in the formula and you get the answer 2. Similarly, we go on with 4 and 5. So now we will find out, is the heuristic edge admissible in the previous graph? Why and why not? So I clearly explained that if it's less than the actual value or equal to the actual value of the cost, so it is admissible. If it's not, it's not admissible. That's the simple logic we can use before it. And I quickly explain this whole thing in which I use the A-star function. So for step first, it goes from node A to node B and checks the thing. This path is less, so it goes to node C, and it also checks for the node D. and the goal node reached is from A to C and node C to node E, and the total path cost is 5, and the number of nodes expanded is 4. Thank you.